Named after Greg Ohm, Ohm's law is arguably one of the most important and fundamental equations to understanding electricity. In a nutshell, Ohm's law showcases us the relationship between resistance, current, and voltage in electricity. The power of Ohm's law comes in the ability to shuffle around the equation to calculate for either voltage, current, or resistance. In this lesson, we will learn how to use these equations for our calculations and when to use which equation and how to mash up different equations together for our calculations. Now, in case you don't know what current, voltage, and resistance is, you can learn these terms by comparing water to electricity. In that case, water pressure can be compared to electrical voltage, the volume of water flowing can be compared to electric current, and the restriction of water flow can be compared to electrical resistance. Now, going back to the equations, if the equations that I showed you earlier felt like too much to remember, you can simply refer to an Ohm's law triangle to derive the appropriate equation for your calculation. To use a triangle, firstly cover up the value that you want to calculate for. Now look at the other two values that are not covered up. If these two variables are side by side, that means they will be multiplied to get the value that you desire. If they're on top of each other like this, they will be divided in that appropriate order, like so. Let's do a quick example here with the circuit. Let's say we know the value of the resistor, but we don't know how much current is flowing through the circuit. We can use Ohm's law to derive the current as this. When an electronics device follows these rules and equations, it is called an ohmic device. And when it doesn't follow these rules and equations, it's called a non-ohmic device. Examples of non-ohmic devices are semiconductors such as transistors and diodes. Now, we have already seen how we can use Ohm's law and shuffle it around to either calculate for resistance, current, or voltage, but you can also substitute other equations into Ohm's law, making it even more flexible for your needs. For example, we can substitute the V or I variables here in Ohm's law and get equations such as these. This makes calculations for your circuits and projects easier and more flexible. Due to us being able to substitute other equations into Ohm's law, we can use something like an Ohm's law pie chart, as you can see here, to do more advanced calculations. Again, these are not new equations per se, but rather equations that are formed by shifting and merging multiple different equations to make them easier for our calculations. This is thanks to the beauty of algebra. And that's it for this video. Thanks for watching.